All right, guys. This is the extra credit packet. How this is going to work is I'm going to do each example problem, and then I'm going to leave the 1 or 2 bonus problems for you to try out on your own. Now, every example problem is designed to mimic exactly what you do in the problems for yourself. So to receive credit, you have to work out the example problems with me as I do them, and you have to then do the 1 or 2 problems on your own. Now, those 1 or 2 problems are treated in exactly the same way as the example. So rewatch the example as many times as you need to try and figure out how to do the other problems on your own. Okay. Now, this video is going to be very long if you haven't already noticed. But the way I see it is if I can put the time in to do this and create this for you, that you can put the time in to hopefully go in and watch it, and because you're gonna get points for it, right? I'm not getting paid any extra to do this, but you're gonna get hopefully a passing grade by the end of it. So I'll leave timestamps in the description if you want to try and skip ahead to certain portions of the packet. If you want to like do a little bit now and then stop and then do a little bit tomorrow, you can kind of skip ahead to those points. Okay. So let's go ahead and get started with the slope and rate of change. So our first problem, we're going to just find the slope between 2 points. So I'm going to open up my sketchpad here, and I'm going to do the example problem. So the example. So there's the slope formula that we're going to use. The slope formula is m equals y2 minus y1 over x2 minus x1. Now, y2 and y1, x2 and x1, they just mean the y values or x values from my first point or my second point. So if I call this my first point, call this my second point, then this is the x value of my first point, the y value of my first point, the x value of my second point, and the y value of my second point. So it's really just a formula for, basically putting 2 numbers into this and just subtracting them. So if I base this off my formula, then I would have my y's on top, which would be 8 minus 16, over my x's on bottom, negative 3 minus 5. So keep in mind that the minus signs are in the formula as well. So use those minus signs. 8 minus 16 would be negative 8, and negative 3 minus 5 would also be negative 8. If you need a calculator to help you in those subtracting, then go for it. But now we've got negative 8 divided by negative 8. This equals 1. So my slope for my example is just 1. Things to look out for, though, if you subtract a negative number, like if I had, for instance, on top it was 4 minus negative 1, that would be the same as 4 plus 1. Okay. Anywho, so the negative's still there, or the minus sign's still there from the formula, but if you plug in a negative number, you have sort of a double negative thing going on. So just be aware of that in case that shows up in example 1 or 2. So now, it's not what I wanted to do. Oops. I was hoping I could create a new screen. All right, there we go. That works out well. I'll just figure out what I did later. All right, moving on. I'll do the example problem for write the equation of the line in slope-intercept form. So the example problem is the slope is 1/2, and the y-intercept is negative 6. All right. So you have to remember that the equation of a line is y equals mx plus b. Y and x are both just part of an ordered pair. The key things here is m and b. Wonder if I can change colors. I bet I can. I just don't know how. M is our slope, and b is our y-intercept. So if I'm going to write an equation in y equals mx plus b form, and I know my slope, that's my m value, and I know my y-intercept, that's my b value, then I'm just going to plug them in, right? M is 1/2 because my slope is 1/2, and b is -6, so I'll have -6. You can write plus -6 if you want to, but plus -6 will be the same as -6. So there's your equation. All I essentially did was just plug in my slope and my y-intercept, and I had my equation. All right, so examples 1 and 2 are very, very similar. Moving along to write the equation of the line in slope-intercept form again, but here we have different information. In this problem, we're given that the slope is 3 and that our line passes through the point -1, 7. So remember what the slope is. For an equation of a line, y equals mx plus b, slope is the m value. So 3 is my m value. So I'm going to go ahead and just plug that in for m. Now, the issue here is I don't have just the b value. You know, the last example that I did, it gave me the y-intercept, just told me what it was. So I knew exactly what the b value was, and I was just able to plug it in as well. But it doesn't say that here. It doesn't give me the b value. What it gives me is an x value and a y value. But I'm going to use these temporarily so that I can find the b value. So I'm going to plug in 7 for y, and I'm going to plug in -1 for x. And I don't have anything to plug in for b yet, but I've got an equation and I can solve it to figure out what b is supposed to be. So 3 times -1 is -3. And so if I want to get this b by itself, then I have to move the -3 to the other side. So I'll add 3 so that I can get rid of it here and move it to the left-hand side. So 7 plus 3 is 10. And now the b is by itself, so that means b is equal to 10. So my final answer of my equation, I know m is 3 and I know b is 10. So when I write it in mx plus b form, I plug in 3 for m and I plug in 10 for b. And there would be my answer. All right, so try the other two on your own. Remember, you're given the slope and an x and y value. So plug in those 3 values and solve the equation, and then make sure you can write your final answer at the end. Okay. Find the rate of change. So it's just the same thing. We're still using the slope formula. Keep in mind your slope formula is equals m equals y2 minus y1 over x2 minus x1. Now, we're given, it's a totally different problem than the ones we've been working on previously. We're given a function here, f of x equals, what is this, 3x squared minus 1. 3x squared minus 1. And we're asked to find the rate of change between 1 and 4. Now, the important thing to notice here is that this is not an ordered pair. This is what it means, just to kind of give you a visual. If I were to graph my function, right, and here's 1 and here's 4, then I'm trying to find the slope between this point on my function and this point on my function. So I'm trying to figure out what is my slope between those 2 points. So to keep it kind of simple, both of these are x values. This is saying x is 1 to x is 4. What I really need, though, is the y values for each of those points. So if I know x is 1, I need to figure out what the y value is there. And if I know x is 4, I also need to know what the y value is there. So how can I find those y values? Well, I've got a function, right? If I plug in these values for x, then I'll be able to figure out what those y values are. So, because f(x) is the same as y, right? So y equals 3x squared plus, or it's minus 1. So let's plug in 1 at first. So let's plug in this 1. We'll have y equals 3, and then we'll do 1 squared. So if you type this in the calculator or you try to work it out yourself, this comes out to be y equals 2. So that means my point, x is 1, y is 2. So I'm going to keep that in mind. Now what I'm going to do is I'm going to plug in 4. So let me just erase it here, right? Let's plug in 4 for x. And if I evaluate this on my calculator, or which probably would be handy, or try to do it by hand. Let's see here. This would be 47. So y equals 47. So that means when x is 4, y is 47. Now I've got 2 points. Now it's the same as the very first problem I did in this video, which is just find the slope between 2 points using the slope formula. So let's call this point 1 and this point 2. Then I'd be doing the y value, 47 minus 2. The x value is 4 minus 1. So this becomes 45 divided by 3, right? Which 45 over 3 or 45 divided by 3 is 15. So there's my answer. So try to recreate that on numbers 1 and 2. Basically, it's the same exact problem, just with different numbers. So do try that on your own work. Remember to show all your work. I'm going to go ahead. Let's get into inverse functions. So, inverse functions. They all are basically kind of the same, just with a slightly more higher level of, solving difficulty, going from linear to quadratics. All right, but let's look at the first example. So the first example, we have y equals 6x plus 11. So here's the thing about inverse functions. Every single time you have an inverse function, your goal, very first thing you got to do is switch the x and the y. So we're going to switch the x and the y. I'm not going to switch anything else. Keep the 6 where it is, keep the 11 where it is. This equation will just be written as x equals 6y plus 11. So 6 stayed where it was, 11 stayed where it was. I just literally wrote x where y was, and I wrote y where x was. Now, all I'm going to do is try to get the y by itself. Solve for y. So every time I do this, there are 2 terms here, 6y and 11. Every time I do this, I'm going to try and move the constant term first, right? I'm not going to get too close to that y just yet. So I'm going to get rid of this 11. So I'll do that by subtracting 11 on both sides. Now on the right side, it disappears and leaves you just 6y. But on the left side, I have x minus 11. Now these are not like terms. You cannot combine x with 11. So you just kind of simply write it out, x minus 11. So it's easier than you think, because sometimes a lot of people overthink. They're going, how do I do x minus 11? I don't know what's going on. But you're really not doing x minus 11. You're just writing it out. Now we're going to try and get rid of the 6. So notice 6 is being multiplied to y. So to get rid of the 6, I'd have to divide everything, both sides, by 6. Now on the right-hand side, the 6 would cancel, leaving you with just y. On the left-hand side, you're probably thinking, how do I divide 6? And the answer is you don't really divide 6. You just kind of write it there. So x minus 11 divided by 6 is good enough, because there's not really anything you can simplify. And that's one way you could write your answer. That's it. That's your answer. You could, the only other thing you could do is just write your answer a little differently. Instead of dividing 6 altogether, you can divide 6 individually to x divided by 6, and then minus 11 divided by 6. Rather than writing it all at one like this, you can just write them separately. So it's the same either way. Just wanted you to know that, because you never know how EOCs are going to write it. But if you want to leave it like I wrote it here, that's perfectly fine. Okay? So remember to switch the x and y, move the constant term, and then make sure you divide if you need to divide. Let's move on to the second example. We have y equals 4x squared minus 5. So it's the same exact first step as the last inverse problem, and that is you need to switch the x and the y. So again, don't move the 4, don't move the squared, don't move the minus 5. Just write x where y is and write y where x is. That's pretty good. All right, now you've got a couple things to work on here. You've got to get the y by itself. So just like the last problem as well, you've got two terms. We're going to focus on getting rid of the term that doesn't have the y, which is the 5. Let's get rid of this first. Add that 5 to both sides. So on the right side, it cancels out. So the right side will just be 4y squared. On the left side, I have x plus 5. But just like the last problem, you don't really add them together. You kind of just write them out, right? X plus 5. So this is the part where a lot of people, I would say half the people I teach, do the wrong thing at the wrong time. So you have to get rid of the 4 first here. The reason being, when you're solving problems, you know your order operations. When you're solving problems, you work these backwards. So you would focus your attention on anything being added or subtracted, which we did, right? We did the minus 5 first, so we took care of that. Then you'd focus on the multiplying or dividing. Then you'd worry about the exponent after. So 4 is what we're multiplying the y. 2 is the exponent. So we'll take care of the multiplying first, and then we'll move on to the exponent. So we'll move this 4. Since we're multiplying by 4, we'll move it by dividing by 4. So that will leave me with y squared on the right. And again, on the left, I don't really have a whole lot going on that I can simplify, so I'm just going to leave it the way I wrote it, x plus 5 over 4. That's totally fine. So now how do I get rid of something squared? Well, the opposite of squaring something is to square root it. So if I square root this side, then I'll cancel out the exponent. But I have to square root the other side as well. So this leaves me y all by itself. And again, none of this over here will really simplify. So it kind of just stays the same. X plus 5 over 4, but all of it's inside the square root sign. And that's my answer. All right. So the one for you is basically the same problem, just with different numbers. So good luck. And then the last example for inverses is y equals 2x plus 3 squared minus 9. This is a much more intense problem, but it's the same first step, which is to switch x and y. So write x where y was and write y where x was. Now focus your attention on everything that's outside your parentheses, okay? So there are two things outside the parentheses. The squared is on the parentheses, so we'll deal with the squared a little bit later, but I'm talking about the 2 here and this minus 9 here. So just like in the last problems, the first thing we moved was the constant term that was being added or subtracted. Well, we're going to do that again here as well. The constant term being subtracted here is minus 9, so we're going to add 9 to both sides, and that'll take care of that. So on the right-hand side, I still have all of this, 2y plus 3 squared, but I don't have the 9 anymore, which is good. The left-hand side is where that 9 is now. So we get x plus 9. Now I'm going to get rid of this 2 that's sitting out here. A lot of people mistakenly distribute this 2. They try to do, if they say 2 with parentheses y plus 3, they think they can distribute this 2, and you can't. You can't do that because this y plus 3 is being squared. This takes precedence over that multiplying of 2. So you can't distribute the 2 for that reason. If the squared wasn't there, you can distribute the 2 all you want. But the squared takes precedence. So we got to get rid of this 2 a different way. Since the 2 is being multiplied to my parentheses, I can get rid of the 2 by dividing it away. So that means dividing everything here by 2. Now on the right-hand side, that just means the 2 will cancel out. So the 2 will be gone, but I'll still have the y plus 3 squared. On the left-hand side, again, like my last example, I'm not really going to be able to simplify this much. So let's just leave it as x plus 9 over 2. All right, now I've got 2 more things. The 3 and the squared. Now, because the squared is outside the parentheses and the 3 is on the inside, I can't really get to the 3 until the squared is gone. So my intention here is getting rid of the squared. So I'm going to get rid of the squared by square rooting it, right? When I square root it, that square will disappear, and it'll leave me with just y plus 3. The y plus 3 doesn't need the parentheses anymore because the squared is gone. So it's just going to be y plus 3. And on the left-hand side, you can see my mess kind of forming. X plus 9 divided by 2 is still there, but now it's all in the square root bracket. Let me move this problem over here. X plus 9 over 2 equals y plus 3. So close, the only thing I need to do now is get rid of this 3. So subtract it on both sides. It's a little bit funny looking because the minus 3 cannot actually go inside the radical. So it's simply just going to be this radical, which is x plus 9 over 2, and then the minus 3 on the outside of it. So basically what happens, this is my final answer, but what happened is all this stuff that I had to get rid of here just kind of gets shucked over to the other side, and it all just sort of builds up like a pile of trash. You don't really put anything together. You don't really combine anything. You just sort of piece it up one by one by one. And eventually the 9, the 2, the squared, and the 3, it all made its way over to the left-hand side. Okay? So again, try your example out. It's the same exact problem, just with different numbers. Now let's move on to transformations. So transformations, there are 4 main transformations. There's a vertical transformation. Oops. Vertical transformations. That's when you're moving a function up or down. There are horizontal transformations. Horizontal. That's when you're moving functions left or right. So make sure you know what horizontal means and vertical. That'll help. There's stretching, which just makes a function kind of skinny or kind of wide. And then there's flipping, which just basically means the function reverses its axis or flips upside down or rotates 180 degrees, however you want to think of it. But here's the way we can tell a transformation. Okay, a vertical shift is when you have a function, okay, but you add or subtract some number. I'm just going to say k as a number, okay? Add or subtract some number at the end of that function. So an example of something like that would be, let's say I had the function x squared. If I add 9 to it at the very end after the x squared, then that means I'm moving vertically 9. Because it's plus, I'd be moving up. If it was minus, I'd be moving down. So let's keep a note of that. If I wrote minus 9, it would still be a vertical shift. It would just be a downwards shift rather than an upwards one. All right. Horizontal shift, left or right. So that will look like when you have a function f of x, but you throw a k value not at the end of it, but inside the function. Right, notice how the k is in with that x now. So what that kind of looks like, if you take a quadratic, right, it would kind of look like, imagine there's parentheses here. It doesn't need to be, but it's helpful for the visuals of this example. If I throw a number not after this function, but in this function, like x plus 9 in the parentheses and then squared, so you can see I still have x squared, but I've got that 9 thrown right in the pot, right? That indicates to me a horizontal shift. So left is when I'm adding and right is when I'm subtracting. So because I have plus 9, it'd be a left shift. If I wrote minus 9, it would have been a right shift. Okay? But notice the difference between that and the original problem that I wrote, right? The 9 being after the squared, and then now the 9 being inside of the squared. That's how you can tell the difference between a vertical shift and a horizontal shift. A stretch is when you multiply a number to your function. So if I had x squared as my function and I said, hey, now it's 5x squared, that's a stretch because I'm multiplying the number to the front of my function. So just to kind of sum up some stuff here, if I had x squared plus 9, remember that plus 9 moves it vertically, moves it upwards. If I then eventually just said, hey, 5x squared plus 9, it's still moving upwards 9, but now because the 5 is there, it's being stretched, which means it'll be skinny as well. And flipping a function, all that does and how you'll know when you're flipping a function is when you have a negative in front of the function. So if all of a sudden I make that negative 5x squared, it's now been flipped over. So any function you have, if you see a negative sign put in front of it, it's been flipped over. So if you had the function x squared plus 3, notice the plus 3, that indicates a vertical shift. But if I just said, hey, it's now negative x squared plus 3, then what I've done, it still has the vertical shift, but now it's flipped upside down if I put the negative in front of it. So it doesn't matter if it's x squared or if it's 2x squared or if it's, I don't know, a smiley face x squared. If I put a negative in front of that, it then becomes a flipped over function, okay? So keep that in mind as we do this example, okay? So I made an example that was pretty out there, an example that had all 4 shifts, just so you can see them all in action. So my original function was f of x equals square root of x. My new function was, what is it? Negative 2 square root x plus 3 minus 12. So my original function I can choose colors. Playing around with the colors for a second. My original function was just the square root of x, right? And I still have my square root of x, but I've added a bunch of new pieces, right? I've added not only a 2, but a negative 2. I've also added this plus 3, and I've also added this minus 12. All of these things that I've thrown into this problem now, thrown in with my square root of x, have transformed this function. They've moved it vertically, horizontally, they stretched it, they flipped it, they did it all. But let's talk about what each piece does. So the minus 12 here, notice the minus 12 where it is. It's after the square root, right? It's not inside of it, it's after it. This indicates something like the vertical shift that I was explaining earlier. A vertical shift. Remember when I showed you x squared plus 9? I said that because the plus 9 was after the squared, that indicated a vertical shift. Well, it's the same thing here. It's a different type of function, but it's still in the same place. Vertical shift, minus 12. Now, because it's minus, that means it's moving down. So let's be specific here and say that, hey, we're moving down 12. All right, let's refocus our attention now on something else. Let's look at this plus 3. Notice where the plus 3 is. It's inside my radical, right? Inside my function, it could be a radical, it could be parentheses, it can be whatever. If it's inside the function, that tells me it's moving horizontally. So this is a horizontal shift. So a plus 3, remember plus would mean left, a minus would mean right. So plus 3 would mean that it's going left 3. So we're going to also make note of that. So there's 2 shifts down. Let me erase some of this red here. It's kind of getting a little distracting. All right, get rid of that as well. So many colors, so many to choose from. Let's go with this pink thing. Okay, now I know negative 2, a lot of you guys like to think of that as one number, and it is one number, but it's actually counting for 2 different things here. So let's just focus on the 2 part first. Because it wasn't there before, right? There wasn't a 2 here before. Multiplying this 2 to my square root. Remember, when I multiply a number to the front of my function, it stretches my function. So I'm here, I'm stretching it, my function, I'm stretching it by a factor of 2. Simple as that. And the last thing I'm going to point out is my negative sign. So I know it's a negative 2. Is that not a different color? I swear I chose a different color. Okay, get off my back. There we go. The negative wasn't there before. The negative flips the function over. So there's all these shifts occurring. I flipped it with the negative. I stretched it with the 2. I moved it left 3 with the plus 3 inside the radical, and I moved it down 12 with the minus 12 outside the radical. So it's kind of just like a matching hide and seek sort of thing. I don't know. But that's how you can tell what transformations are occurring from an equation. Okay. Notice what the equation originally was, and then point out all the different things that occurred. And based on where those things are, can tell you a lot about what type of transformation it's representing. So your examples don't have all 4 transformations, but they do have several of them. So be on the lookout for that. And go back and rewind and watch me explain all those transformations if you are having a little bit of hard time there. Okay. All right, now we're going to move on to systems. So systems, the first type of problem we're going to look at is check whether the given point is the solution to the system. So my example, let's go back to black here. Did I choose black? Yes, I did. Okay. My example is I have the point 1, 7, and I have the system 4x plus 3y equal to 25. And I have the equation y equals negative 4x plus 11. Okay, so I'm not asked to solve the solution. I'm only asked to say whether this point that I'm given here, whether that's the solution or not. Now, the convenient thing is this point, it's just an x and a y value. If that point is the solution, then that means that 1 and 7, if I were to plug them in, it would give both equations would be true. Both equations would be would work out and equal what they're supposed to equal. So let me kind of demonstrate. All I'm going to do here is plug in 1 where I see x and plug in 7 where I see y. But I'm going to do the first equation first. So I had 4x plus 3y equals 25, right? But I'm going to plug in 1 for x and I'm plugging 7 for y. So that's going to be 4 times 1 plus 3 times 7 equals 25. So now let the calculator do the work. Just all you got to do is verify that this all equals what it's supposed to equal, right? 4 times 1 is 4, and 3 times 7 is 21. So what's 4 plus 21? 4 plus 21 is 25. So 25 equals 25. That's obviously true, right? So because that's true, that's half the battle, but that's good. That doesn't mean anything right now, but it's a good start. What I need to do now, though, is I need to check the other equation. It's not going to be good enough to just check one. I have to check both. So let's check the other equation. The other equation was y equals negative 4x plus 11. Remember, I'm going to plug in 7 for y, and I'm going to plug in 1 for x. And I'll just see if this all comes out to be what it's supposed to be. So 7 equals negative 4 times 1 is negative 4 plus 11. Negative 4 plus 11 is 7, and 7 equals 7. So this equation works as well. So since the point works in both, emphasis on both equations, then that means that that point is a solution. I can say yes, the point 1, 7 is the solution. And then we can have fireworks, and the crowd goes crazy. I just love writing on this thing, by the way. All right. So if it works in one equation, but it doesn't work in the other, then it's no. It has to work in both, okay? So keep that in mind. It might work in the first equation, but it might not work in the second. So be careful. And if that happens, then it would not have been the solution. All right, so moving on. Now we're going to solve using elimination. So this is where, a lot of interesting things happen. So we have the system 5x plus y equals, Jesus. 5x plus 3y equals 30, and 3x minus y equals 32. So I'm going to solve this using elimination. Now, what I need to do is assure that either the x terms or y terms cancel out if I were to essentially just add the equations together, right? If I just add these across, currently 5x plus 3x would be 8x. 3 minus 1 would be 2y. And 30 and 32 would equal 62. But I can't. That's not going to work. That's useless to me because I didn't eliminate x or y. Right? 8x, 2y. I need one of those variables to cancel themselves out. So I've got options. Okay, so I can either eliminate x or y. But let's go through both options and we'll decide what's best for us. If I want to eliminate x's, okay, if I want to eliminate my x terms, I've got to think of a common multiple of 5 and 3. Not a common factor, a common multiple. So what's a common number that 5 can multiply to and 3 can multiply to? Well, multiples of 5 are 5, 10, 15, 20. These are what multiples are. Multiples of 3 are 3, 6, 9, 12, 15, 18, etc. Right? So I just need to find a common multiple. It doesn't even have to be the least common multiple. It just has to be any common multiple. But the least would be probably the most efficient. Now, 3 and 5 can both be multiplied to make 15. So here's what I'm going to do. My goal is to make this 15x and this negative 15x. It doesn't really matter which one's negative, as long as one of them is, because I need a positive with a negative to cancel out. So, how am I going to make the top? How do I make 5x 15x? Well, I'd have to multiply it by 3, right? 3 times 5 would make 15x. The catch is I have to multiply that 3 with all of these terms here. Okay, and we'll do that in a moment. But let's focus our attention on the second equation now. If I want this to be negative 15x, then what do I need to multiply it by? I'll have to multiply it by negative 5, because negative 5 times 3 would be negative 15x. So I've got my goal in mind. Now I'm going to multiply and execute the problem. So when I multiply the top equation by 3 times 5 would become 15x, which is good. That's what I want. 3 times 3y would be 9y. And 3 times 30 would be 90. Now I'll multiply the bottom equation by negative 5. So negative 5 times 3x would be negative 15x, which is good. Negative 5 times negative y becomes a positive 5y. And negative 5 times 32 becomes negative 160. So calculator's probably going to help you out a little bit here. All right, so now this is good. Now the x's are ready to be canceled out. So when I add the equations together, 15x minus 15x, that cancels out, right? That's gone. I don't have to worry about it. It'd be 0x, which is useless. The y's, positive 9y and positive 5y. Well, 9 plus 5 is 14, so that would be 14y. And then 90 minus 160. 90 minus 160 is negative 70. So I just solved this equation now for y, right? Divide by 14. And I have y equals, I think that's 6, but let me check my calculator. 70 divided by 14 is 5. Okay, so this is why you check the calculator. All right, cool. So it's negative 5, though, because it's negative 70 divided by 14. So y equals negative 5. That's only half my answer, though, because remember, for systems, the solution is an ordered pair. It's a point. So I know the y value is negative 5. But here's the rest is pretty easy, though. I can just take this information now that I know what y is. I can plug it back in for y. It doesn't matter which equation I plug it into. But let me plug it in for y and we'll solve. So I'm just going to plug it into the bottom equation because, why not? So the bottom equation is 3x minus y equals 32, right? But I'm going to plug in negative 5 for y. So this would be 3x minus negative 5. Now you got to be careful if you do this because it's a minus and then I'm subtracting a negative number. So that's why I put the parentheses there. So this would really be 3x plus 5 equals 32. And now subtract 5. This gives me 3x equal to 27. And then when you divide by 3, you get x equal to 9. So my answer, x is 9 and y is negative 5. So my answer is that ordered pair. So the trick is really to this problem is trying to figure out, what are you going to multiply by to try and get these to cancel out? That's tricky. And I'm willing to help you out in tutoring if you need to. But rewatch my explanation again if you're trying to do that the other problems on your own. All right, now I'm going to move on to solving using substitution. So my example, 4x minus y equals 29, and x equals negative 5y plus 2. All right. Now I'm going to use substitution here. The reason I'm going to use substitution, and the problem set up for it, is because x here is all by itself, right? X equals this. Now, if I just pretended like we didn't know what this was, right? If I just said, hey, x equals 2, you know what you would do? You would probably just plug in 2 right there, right? And you would have the equation 4 times 2 minus y equals 29. And that's all well and good. That is substitution, though, at its finest. But here's the thing. X is not equal to, unfortunately. X equals that. Negative 5y plus 2. But the principle is still the same. We're going to take this and we're going to plug it in for x. So it's not a number, it's an expression, but it works pretty much the same way. So the equation is 4, right? But instead of multiplying it by x, I'm going to multiply it by negative 5y plus 2. I still have the rest of the equation stays the same. The minus y is still there, and the 29 is still there. All right, I just plugged in the negative 5y plus 2 for x. So now I have no x anymore, right? My equation is just full of y's, and that's good because I can work this out and I can try to figure out solve for y. So the first thing I'm going to do is distribute this 4. So 4 times negative 5y would be negative 20y, and 4 times 2 would be positive 8. Be careful on your distribution. A lot of times we can run into some simple little mistakes there. So just check your math. The minus y and the 29 all stayed the same for that part. So notice I've got 2 y terms here. Both of them, of course, they're meaning that they're like terms, so I can combine them. So it's negative 20 and it's negative 1. So if you're typing it in a calculator, you're doing negative 20 minus 1. And that comes out to be negative 21. So that's negative 21y. The plus 8 still stayed the same. The 29 still stayed the same. All I did was combine the y's together. So negative 21. And now I'm solving here for y. So let's subtract 8, right? Because it's a term that is not the y term. So I'm going to move it first. So it leaves me with negative 21y equal to 29 minus 8 is positive 21. And when I divide by this negative 21, I get y equal to negative 1. So again, that's only half my answer. My answer is supposed to be an order pair. But I know the y is negative 1, which is helpful. So what I'm going to do is I'm just going to take the y equals negative 1, and I'm going to plug it in for y. It doesn't matter if I use the top equation or the bottom equation. But I'm going to go ahead and just use the bottom equation, right? The bottom equation is x equals negative 5y plus 2, but I'm going to put negative 1 in for y. So x equals negative 5 times negative 1, right? That's me plugging it in for y, plus 2. So this gives me a positive 5, right? Plus 2, and 5 plus 2 is 7. So x equals 7. So my answer then is 7, negative 1. Okay. So your problem again works exactly the same. You just have different numbers. Okay. So good luck trying to do that. All right. Now moving on to the backside. I can tell this video again kind of long. Oh, the football game. Okay, I'm watching the football game, by the way. It's the Patriots versus Alliance, not to date this video. Okay. I'm going to solve each word problem. So let's explain the word problem. So my word problem says, Chase and Sarah went to a candy store. Chase bought 5 pieces of fudge and 3 pieces of bubblegum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubblegum for a total of $3.60. find the price for one piece of fudge and one piece of bubblegum. So when you read this, I know you're kind of things just get clouded, but take it sentence by sentence and try to write an equation. So Chase and Sarah went to the candy store. That does not tell us anything about our equation. So let's just skip that. Second sentence, Chase bought 5 pieces of fudge and 3 pieces of bubblegum for a total of $5.70. Now I can make that an equation, right? 5 pieces of fudge, so I'll just say 5F, and so plus 3 pieces of bubblegum, so I'll just use G for gum, for a total of $5.70, right? There's an equation, just like that. Now let's read the next sentence. Sarah bought 2 pieces of fudge, so that's 2F, and 10 pieces of bubblegum for another total of $3.60. There you go. So it's a word problem, but now it's no longer a word problem. Now it's just a regular systems problem. Now you can solve this using any method you like, but I highly recommend the elimination method because this is set up very similarly to the elimination method problem that we did earlier. So if you want to see the elimination method, go back and rewind it. But to explain it again, I got to cancel out either F or G. Now, 5 and 2 do not cancel out for Fs. 3 and 10 do not cancel out for Gs. So I've got to think a little bit here. Let's say I want to cancel out the Fs. All right, then I'm looking at 5 and I'm looking at 2 and I'm thinking, what are common multiples of 5 and 2? And the first thing that comes to my mind is 10, right? I know that 5 can be multiplied to make 10. I know 2 can be multiplied to make 10. So let's try to make 5F 10F, and let's try to make 2F negative 10F. So if I want the top to be if I want the top to be 10F, then what do I need to multiply 5F by to make that happen? I have to multiply it by 2, because 2 times 5 would make 10F. In the bottom equation, I want it to be negative 10F. So I'll have to multiply it by negative 5, so that it can become negative 10F. Now, here's a little bit of advice before I finish this problem. If you have a hard time coming up with a number that these can multiply to, you can always just multiply them by each other, right? I mean, I don't know how else to say it, but you can always, like I said, I mean, it's just basically these are the same numbers, just flipped the other way around. So I'm just saying, you know, if we had 9F, for example, and 5F, when in doubt, I know I can multiply this by 5 and this by 9, you know, because 5 times 9 would be the same as 9 times 5. Just need to make sure one of them is negative, okay, so that they would cancel. So just a word of advice for you, a little tip. You can always do that if you're struggling. All right, but I decided on 2 and negative 5 here, so let me multiply these by 2. So the top equation multiplied by 2 would become, say 2 times 5 would be 10F, 2 times 3G would be 6G, and 2 times 570 would be 1140. Now, the second equation multiplied by negative 5. So negative 5 times 2F would be negative 10F. Negative 5 times 10 would be negative 50G. And negative 5 times 360 is negative 18 even. I'm going to go ahead and put the decimals there just because it's talking about money. So when I write 18.00, it looks like $18. All right, so now we're ready to add these equations up, right? 10F minus 10F would cancel out. That's good. That's the whole point of the problem. All right, 6 minus 50 would be negative 44G. And 1140 minus 18 would be negative 660. So now, if I solve for G, I'll divide by negative 44. And so G is going to equal, and I'm going to need my calculator to check this. 660, negative 660 divided by 44 equals 0.15. So that means a piece of gum is 15 cents. All All right, now all I need to do is find out how much the fudge cost. So I got G. I can plug that G in to either equation. It won't matter. I'm going to just plug it into the first equation. So 5F plus 3G equaled 570. So I'm going to put 0.15 in for G. So 5F plus 3 times 0.15 equals 570. So when I multiply 3 times 0.5, I get 0.45. And when I subtract 0.45 from both sides, I have 5F equals 525. So when I divide those both sides by 5, F equals $1.05. So I'm sure a calculator, I did that kind of quickly because I kind of knew a little bit of that. But yeah, definitely use a calculator to do some of the adding, subtracting, and dividing there for sure. Okay. All right, but there it is. So remember to read the sentences carefully because that's what makes the word problems converted into a normal problem, and then just go back and do the methods that you've been taught how to do. Okay. So now we're moving on to the last section, quadratics. So for the first example problem, I'm looking to identify zeros, axis symmetry, vertex, and max or min. So let's see if I can close this out and try to go to the graph on here so that I can actually use it. Okay. So let me write, please. Let me write on this. I hope you are. I haven't figured out how to do this yet, but gosh. Okay. There's a way to do this. I just don't remember what it was. Screen sketch. Yeah, that's what I want to do. Okay. So my example, I'm looking for the zeros. Let's do that first. So zeros. Zeros are the x-intercepts. They can also be known as solutions. Okay. But that means I'm looking here and here. Now, it doesn't look like it was perfect on that graph, but I'm going to go ahead and, for the sake of my example, say, hey, it's crossing at x equal to 2 and x equal 8. So these are my zeros. All right, so there you go. I'm going to erase it just because, well, maybe I'll leave it there. Maybe I have enough room. Now let's look at the axis of symmetry. Actually, yeah, let's look at the axis of symmetry. So the axis of symmetry is the line that splits right down the middle of my function. Right, that splits the parabola right in half. And that's going straight through 5 on the x-axis. So the axis of symmetry is x equal to 5. Okay? It's not y equals, it's always x equals because we're going through the x-axis, not the y-axis. All right, so there's your axis of symmetry. Now the vertex is the point at the very tip of your parabola. So here it's at the very, very top. That order pair, if I try to find it, its x value is -5. So remember, the vertex is written as an ordered pair. The x value is negative. Oh, I'm sorry, it's +5. Oopsie. And its y value is 8. The point of our vertex is 5, 8. So there's your vertex. And then the last thing is our max or min. So in this case, we have a maximum because the vertex is at the very, very top, right, of our parabola. There's no point higher than that. So the vertex is a maximum. So remember, max and min is always referring to the vertex. But where is that max at? Well, as you can see, its highest y value is 8. So the max is at y equal to 8. And there you have it. All right, so you can try the other problem on your own. All right. Now for the zeros, I know the zeros aren't perfect, but let's just go ahead and assume in your problem, like I assumed in my problem, what the zeros were. Okay? I'll be cool with that. All right, back to my screen pad. All right, or my sketch pad. All right, if you want to find the axis symmetry and vertex, but you don't have the graph. So find the axis symmetry and vertex, but no graph. My example problem is y equals 2x squared plus 8x minus 5. So to find the axis of symmetry, and I'm just going to abbreviate that AOS for axis of symmetry, the formula to find it is -b over 2a. So remember that here, it's ax squared plus bx plus c. So that means here a is equal to 2, b is equal to 8, and c is equal to -5, since it is -5. So I'm just going to plug those a and b values into my formula. So that'll be -8 over 2 times my a value, which is 2. So if I work this out, I've got -8 over 2 times 2, which is 4. And -8 divided by 4 is -2. So there's my axis of symmetry. My axis of symmetry is x equal to -2. Now, how do I find the vertex? Well, I've already done half the work for my vertex. Because the axis of symmetry, this x value is the x value of my vertex. All I need to do is figure out the y value. So if I want to figure out the y value that goes with -2, then all I'm going to do is take this -2 and I'm going to plug it back into my function for x. So I'm going to plug in -2 for x. So that's going to be 2 times -2 squared plus 8 times -2 minus 5. So if you type that in the calculator exactly like that, you'll get an answer. I don't have that on me right now, so I'm going to try and do this in my head. So that would be, let's see, 4 times 2, which would be 8. This would be -16, minus 5. I believe that comes out to be -13. So that means my vertex is -2, -13. There you go. Okay, so remember to use this formula. That'll get you the x value. Once you have the x value, just plug it in, and you'll get the y value. Okay? So try your problems out. So next, we have find the solutions. So finding the solutions, that means the zeros. That means the x-intercepts. But it's a lot different than it was before. And I'm actually going to do it 2 different ways for you. So y equals 2x squared. This is my example. Plus 7x minus 15. Now, the most efficient way to do this problem is to factor it, if you can factor it. And you can also use the quadratic formula. I'm going to do both here. Hopefully, I can manage to do it on this one screen. But I'm going to try and do both. So if I'm going to factor this, I've got 3 terms. I got a trinomial here. Now, the first thing I'm going to do is look to see if there's a GCF in those 3 terms. By that, I mean, do these 3 terms, 2x squared, 7x, and -15, can I divide any one number out of all 3 of them? The answer is no. There's no one number besides 1 that would divide all 3. So there's no GCF. So because there are 3 terms, though, I'm going to try my product and sum method. So my product and sum method, I need to multiply a times c together, and then it's not negative b, it's just b. And then b value, and I need to find 2 numbers that multiply to a times c and add to b. So just set it up like that. So my a value here, notice my a value is 2, my b value is 7, and my c value is -15. So if I'm going to set up the x thingy, right, a times c is -30. That's positive 2 times -15 is -30. The b value is 7. So now my goal, now that I've set up my x thing, is to figure out what 2 numbers are going to multiply to make -30 and add to make 7. It's kind of tricky, but you got to think of all the numbers that multiply to make -30 and add to 7. So a little bit of advice. It multiplies to make a negative, right? So one number is positive and the other number is negative. Because 2 positive numbers would multiply to make a positive, 2 negative numbers would make a positive as well. So one number's got to be positive, the other's got to be negative. So numbers that multiply to 30, there's 5 times 6, there's 15 times 2, there's 10 times 3. And if you think about all those combinations, the answer here would be a positive 10 and a negative 3. Positive 10 times -3 is -30, and 10 minus 3 is 7, so it works for both. So both of these become x terms, a positive 10x and -3x. And what we're going to do with those x terms is replace that 7x from the problem. So the equation is, 2x squared But I'm not going to write the plus 7x. I'm going to write the plus 10x minus 3x. And then the minus 15 stays at the end as well. So the first term, the 2x squared, and the last term, minus 15, stay the same, but the middle part changes. Okay, so remember to use these numbers here to replace that bx term. So now all you got to do is factor by grouping. So group the first two terms together and the last two terms together, and just do GCF of each group. So the first group, what does 2x squared and 10x have in common, and what can they both be divided by? Well, both 2 and 10 can be divided by 2, and both terms have an x as well. So I'm going to factor 2x out. Now when I divide 2x, right, 2 divided by 2 is going to cancel out. One of these x's will cancel with one from above, so that'll leave me with just a single x remaining. 10 divided by 2 is 5, and those x's both cancel out as well, so I get x plus 5. Now my second group, both can be divided by 3, but I'm going to divide by a negative 3. Basically, I'll divide by a negative anytime this first number is negative. I'll always divide by the negative if that number is negative as well. So I'm going to pull the negative 3 out, and then I'm going to have negative 3's cancel, so I'm just left with x, and negative 15 divided by negative 3 is positive 5. So my two factors are going to be 2x minus 3 and x plus 5. But remember, we're not done because these equal 0. Okay? So all I got to do is solve both of these equal to 0. So if I take 2x minus 3 and equal it to 0, and I take x plus 5 and I equal it to 0, my two solutions, you can work them out, I hope, on your own, because I don't have any room left there. Two solutions would be x equal to 3 halves and x equal to negative 5. Now, if factoring's too much for you, okay, sometimes it's the more efficient way. Sometimes, if you get good at it, can be a lot faster. But if you're having struggle factoring, then you can always use the quadratic formula. So the quadratic formula is negative b plus minus the square root of b squared minus 4ac over 2 times a. So I already know what a, b, and c are, so I'm just going to plug them in the formula. I'm going to get the same answers, but I'm just going to do this problem this way in case you can't factor your problems. So that's negative b. Now b is 7, so this becomes negative 7. Plus and minus the square root. Now b squared. B is 7, so I'm going to do 7 squared. I like to put that in parentheses too, because if I use my calculator, and I don't use parentheses, and things can go wrong. So I like to put that in parentheses. Minus 4 times a. A is 2 times c, and c is negative 15. And all divided by 2 times a, and a is 2. So if you want to type in your calculator, everything you see underneath this radical, you can. Okay, so 7 squared minus 4 times 2 and negative 15. All right, that would get you, let's see, I'm going to try and do this in my head first because I don't have my calculator. But if you want to type it in the calculator, you should get the same number I do. Let's see, 49 plus 120. Yeah. All right, so that would be 169. Okay. And I didn't do the square root yet. I just did the numbers on the inside. Okay. So, and then divided by 2 times 2, which is 4. So now the square root of 169, that's a perfect square. You can type that in the calculator and get a number. Square root of 169 is 13. So that's negative 7 plus minus 13 over 4, right? So there's two things going on here. There's plus and there's minus. So there's negative 7 plus 13 over 4. And then there's also negative 7 minus 13 over 4. So if you work these out, negative 7 plus 13 is 6. You get 6 over 4. Negative 7 minus 13 is negative 20 over 4. Now, if you reduce 6 over 4, you get 3 halves. And if you simplify negative 20 divided by 4, you get negative 5. So it's the same answers as before, okay? But you can choose whichever method you want to use, okay? Quadratic formula is safer as long as you can multiply things correctly. But factoring is sometimes the more preferred and more efficient way to do things. All right, we're almost done. Got solving the word problems now. Okay, so a toy rocket was launched into the air from the ground. The equation h of t equals negative 16 t squared plus 256t models the height of the rocket after t seconds. So how long is the rocket in the air? So if you want to visualize the graph of this, it probably looks something like this, right? Rocket goes up in the air and it comes down, and this is time. So this would be 0 seconds, this would be some kind of seconds. So the first question is asking, how long is it in the air? So we got to figure out, how long is it from this point on the ground to this point on the ground? How much time does that take? Now to do that, what we're doing is we're solving for the zeros, right? We're solving for the x-intercepts. So to solve for zeros, I'm going to take my equation, negative 16t squared plus 256t, and I'm going to set it equal to 0. That's a t there, by the way. So you can use the quadratic formula if you're a fan of that, but this would be a lot easier to factor. So these two terms, they have a GCF in common. I'm just going to factor, and I'll solve for 0. Both of these terms can be divided by t, of course, because they both have a t in it, but they also can both be divided by 16. Now, I'm going to divide by negative 16. My rule here is anytime the first term is negative, I divide by a negative with it, just so the first term becomes positive. So I don't have to divide by the negative, but I'm going to because it's going to make the rest of the problem a little bit easier to understand. So when I factor that out, I've got negative 16t on the outside, and then I'll have t minus 16 on the inside, right? The first term, the negative 16, all that cancels out, and I'm just left with t. Here, the second term, the t's cancel, and 256 divided by negative 16 is negative 16. So that's where that minus 16 comes from. So I factored. Now all I have are two pieces of an equation equal to 0. I've got negative 16t equal to 0, and I've got t minus 16 equal to 0. So when I solve for each of these, I get t equal to 0, right? 0 divided by negative 16 is still 0. And this one, I get t equal to 16. So the rocket was in the air from 0 seconds to 16 seconds. So that means it was in the air for a total of 16 seconds. Okay, and that would be part A. I'm going to erase that and do part B. So how long will it take for the rocket to reach its maximum height? So let me write the function back down. H of t equals negative 16t squared plus 256t. So how long will it take for the rocket to reach its maximum height? Now the key word here is maximum. Maximum, remember if you're visualizing your rocket, the maximum height would be here. So we're asked to figure out what time is it when it reached its maximum height. And to do that, notice the maximum height is the vertex, but the time is where the axis of symmetry is. So really, part B, when it's asking me what time, it's really only asking me the axis of symmetry. So that's just, remember the formula, negative b over 2a. So that means A is negative 16 and B is 256. So this would be negative 256 divided by 2 times negative 16. Now this is negative 256 and this is negative 32. When you divide those, the negatives cancel, we get a positive 8. So that means 8 seconds. The rocket is at its maximum height at 8 seconds. So there's part B. Part C is related to this. What is that maximum height? Well, if I know the maximum height occurs at 8 seconds, then I can take that 8, because it is a t value, and plug it in for t to find out the height at that time. So we'll have negative 16, plug in 8, 256, plug in 8. And I worked all that out. And I don't know, I don't have a calculator, but if you had a calculator, this would be faster. Let's see here. So negative 16 times 4. And 256 times change. All right. So the answer there is 1,024 feet, meters. I don't remember. Feet, I think. But there you have it. That is how high the rocket flew. Okay. So that would be the answer to part C. All right, guys, that's going to conclude it, man. That took a long time, but I went through the trouble to make this video for you. I hope it helps you. I hope you learned something from it, and I hope it pays off in the end, that it was worth doing, because I really want you to pass, and this is a sure way that you can make that happen, okay? So I will see you in another video, okay? Have a good time. Good luck. Bye-bye.